Welcome everyone to a session on automata theory and computability. In today's session, let us solve few more problems on regular languages by building a DFSM. We'll start with a very simple question that is displayed on the screen. So here the language L is made up of a string W from the alphabet set 0 and 1, and the definition of the language says strings of any length. So language should be able to accept string of any length. So this is a very simple problem. You cannot get a problem simpler than this. So let us see how to solve this problem. Okay, now let us stick to the basics. The first question what we would ask ourselves is, what is the simplest valid string that is accepted by the language, right? So strings of any length. So what can be the smallest string? String of length 0, right? String of length 0 is valid according to the definition. So string of length 0 is represented by epsilon, right? So epsilon is totally valid. And let us build the skeleton of the DFSM by considering this. We'll start with the starting state. Okay, so Q0, when Q0 doesn't, we start with Q0, and if Q0 encounters string of length 0 or no string at all, which is represented as epsilon, is that accepted? Yes, that is totally fine according to the definition of the language. So we should mark Q0 itself as accepting, right? Okay. So is epsilon accepted? Yes. You are in Q0 and you don't encounter anything. That is totally fine and it is accepted, right? Now let us improvise. What if I encounter 0 or 1? So is this is a string of length 1, right? Is it valid according to the definition? Totally true, totally true. So 0 should be accepted, 1 should also be accepted. So what I need to do? Do I need to have a separate transition to different accepting state? Not required, not necessary. What I will do, I'll have a self loop to the same state. So Q0 upon 0 or Q0 upon 1, I'll remain in Q0, which is accepted, right? What about any possible combination? Yes. So Q0 upon 0, I'll remain in Q0. Q0 upon 1, I'll remain in Q0. Q0 upon 1 again, remain in Q0. Q0 upon 0, I'll remain in Q0. So by encountering the entire string, I'll remain in Q0, which happens to be the accepting state, right? So this is totally accepted. So this is a special language. Normally, will not be asked in any exams or any kind of competitive exams, because this is a simplest string which does not have a rejecting state, right? Anything is accepted. Anything and everything is accepted, right? We'll see a few more problems. Okay, this language says L is made up of W string from the alphabet set A and B. For a change, we have A and B as alphabet set, and the definition says should accept strings contains no more than 1B. So language accepts a string that contains no more than 1B. Okay, let us design a DFSM for this. Okay, we'll stick to the basic. So according to the question, what is the simplest string that is accepted? String of length 0, right? So is epsilon is a string of length 0. Does it contain any B? No. So this is totally valid according to the definition, right? So this with this we'll build the skeleton of the DFS. Okay. So I am in Q0 and Q0 encounters epsilon, or in other words, Q0 encounters no string at all. So this should be marked as accepting. What about A? Is A, does it contain any occurrence of B? It contains 0 occurrence of B, right? A is a string that contains no B at all. So that is also totally fine according to the definition. So if a Q0 encounters A, what should I do? I'll remain in Q0 because that should be accepted. What if I encounter more A? Yes, I'll remain in Q0 because this contains no more than 1B. In fact, it contains no B at all, right? Okay. Now, now comes the tricky part. What if I encounter a single B? Is this valid according to the language? Yes, this is totally valid because the language says strings contains no more than 1B. So 1B is valid. Now, a single B need to be accepted, right? So can I remain in Q naught state? Answer is no. I should not remain in Q naught state. So let me explain why I cannot remain. Okay. So Q naught upon B, yes, I'll remain in Q naught, which is accepted. That is totally fine. But what if I encounter two Bs? What will happen? First B, for the first B, I'll remain in Q naught. Now I'm in Q naught and I'll encounter one more B. So I will again remain in, I will have a self loop and I'll remain in Q naught, right? But this is a string that is invalid according to the definition of the language. So what need to be done? This cannot be accepted, right? So I have to, yeah, I have to go to a state other than the starting state, right? I cannot remain in starting state. I cannot have a self loop because that will accept any number of B's, right? So what will I do? For the first occurrence of B, I'll go to a state from Q naught that will be marked as accepting, right? So I'll go to Q1. So is Q1 accepting? Yes. So single B, Q naught upon B, I'll go to Q1, which should be marked as accepting, right? So now it is fine. Okay. Now, what about A? So any A is accepted, A followed by a single B is also accepted. What if I get more A's, right? This should be accepted because this contains no more than one B, right? So what happens? Q naught upon A, I'll remain in Q naught. Then B, when I encounter B, I'll go to Q1. So now I'm in Q1. Now I encounter more A's. What should be done? I should remain in Q1, right? So Q1 upon A, I'll remain in Q1. Yes. So this DFSM is totally valid and accepts all the valid strings. Now, what if I encounter more B's, right? Okay. So if I take A, B, B, what will happen? Does this violate the definition of the language? Yes. This violates the definition of the language. So this should be rejected. So what will happen? Q naught upon A, I'll remain in Q naught. Q naught upon B, I'll go to Q1. Now, Q naught upon Q1 upon B, I don't have a transition. See, Q1 upon B, I don't have a transition. So what will happen? The machine will not know where to go. Since there is no definition for B upon Q1, the machine will not know where to go. So that string, the entire string will be rejected. Okay, and such kind of DFSM is called as incomplete DFSM, which is already which has explained in the previous session, right? Okay. But if I have to design a complete DFSM, what I need to do? I need to write one dead state or trap state, right? So let us design a complete DFSM because this is a simplest transition diagram which contains only two states, right? So we can afford to have a better solution. Okay. Now Q1 upon B, what I will do is I will make a transition to a new state called as D. This is the dead state and this is non-accepting. And once I go to a dead state, any more encounter of A or B will be rejected or I'll remain in D itself. There is no possible way of going back to the accepting state because I've already encountered more than one B, right? Now, for example, if I have AB, is this accepted? Yes. Q naught upon A, I'll remain in Q naught. Q naught upon B, I'll go to Q1, accepted. What if I encounter A, B, 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 A? This will be rejected. Let us see how. Q naught upon A, Q naught upon B, I'll go to Q1, which is accepted. Q1 upon B, I'll go to dead state. Now in the dead state, I'll encounter B and A, I'll remain in dead state, so this will be rejected. Okay. We'll see a few more examples. Let's see this problem. Here the language L is made up of string W from the alphabet 0 and 1 and the definition says the language will accept strings of even length. Okay, let us see the solution for this. So what is the smallest string that is valid according to the definition of the language? What is the string that is the smallest even length? What is the smallest even number? The smallest even number is 0, right? The string of length, so the string of length 0, which is epsilon, should be accepted, right? Okay. So we'll build the skeleton of the DFSM by considering this. I'll have a starting state q naught, and if q naught encounters epsilon or no string at all, that should be marked as accepting, right? Okay. So skeleton is ready, right? Now what if I encounter one occurrence of 0 or 1, either 0 or 1? What will happen? This is a string of length 1, right? So this is odd number. So what need to be done? This need to be rejected, right? So if I encounter, if q not encounter either 0 or 1, then that should be rejected, right? So I'll come to q1 state, which is the rejecting state. Okay. What if after coming to q1, I'll encounter more occurrences of zeros or 1? Okay. For example, 0 0 or 0 1. So, so is this valid? Yes. This is a string of length 2, which is even, right? This is also, this should also be valid. In fact, 1 1 or 1 0. So all these are valid, right? String of length 0. So what will happen? Q naught upon 0. Q naught upon 0. Let us consider this example. Q naught upon 0. I'll go to Q1. I'll go to Q1. Now in Q1, I encounter one more 0. So what should I do? Now the total length has become even, right? So I should be in a accepting state, isn't it? So what I'll do? I'll go back to I'll go back to starting state for 0 or 1. Okay. So is this accepted? Yes. You take any example, 0 0 0. So this should be rejected, right? So let us see whether it will be rejected. Q naught upon 0. Q naught upon 0, I'll go to Q1, which is rejected. Q1 upon 0, I'll go back to Q naught, which makes it accepted, but we did not encounter the end of the string. Then I encounter one more 0. So Q naught upon 0, I'll go to Q1. So at the end, I'll end up in Q1, which is the rejected state, right? What about this? Okay. So this will be accepted. Q naught upon 0, Q naught upon 1, I'll go to Q1, Q1 upon 1, I'll go to Q naught, Q naught upon 0, I'll go to Q1 again, Q1 upon 0, I'll go to Q naught. So at the end, I'll end up in Q naught, which happens to be the accepting state. So this will be accepted, right? Okay. Let's see the next one. In this language, which is made up of 0 and 1, the definition says strings that have odd ones and any number of zeros. Okay, so all the strings that has odd number of ones and they are not bothered about the number of zeros that is occurred in the string should be accepted, right? Okay. So again, let us stick to the basics. We have to consider the smallest length string that is valid according to the language to build the skeleton of the DFSM. So I'll start with the Q naught. Now, what is the smallest valid string according to the definition of the language? Single one, right? Right? Epsilon is not valid because it doesn't contain uh, odd number of ones. In fact, it contains even number of ones, right? So if this is rejected, so this is not the smallest one in this case. So single occurrence of 1 is the smallest valid string according to the definition. So q naught upon 1, what should I do? I will go to a state q1 that should be marked as accepted. Okay. So our skeleton of the DFSM is ready. Now, what question they have asked? They have asked odd number of ones and any number of zeros. So we are not bothered about the number of zeros that we encounter, right? Isn't it? The main condition is I should have odd number of ones. Okay. So what if I encounter 0? This is rejected because of course it satisfies one part of the condition, that is it has any number of zeros. Here it has one occurrence of 0, but the number of ones in the string is 0, which happens to be even. So this entire string is rejected, right? So what happens if I encounter 0 in q naught? I will remain in Q naught because that should not be accepted, right? Okay. So any zeros for that matter will be rejected, right? Whether it is odd or even, it will be rejected. But if I have 1 with it, okay, 1 with the 0, any number of zeros, then that will be accepted. I'll go to the Q1 state, right? Now after I encounter 1, what if I encounter more zeros? Will this be accepted? Yes, because we are not bothered about the number of zeros. In fact, what we are focusing is the number of 1 should be odd number, right? So if I encounter more zeros in Q1 state, I will remain in Q1, right? Because this contains odd number. I'll come to Q1 only if I encounter odd number of 1, right? Okay. Now coming to the invalid string. What if I encounter even number of 1? Okay, so for the first occurrence of 1, I'll go to Q1, which is fine, which is accepted. If I encounter one more 1, then that the number of ones in the string will be even, right? So I should be ending up in a rejected state, right? So Q1 upon 1, I should go back to Q naught, right? And I should mark this as okay, and Q naught is already marked as non-accepting, right? Okay. So all the invalid string will be in this way will be rejected, right? So take any example. 0 will be rejected because it contains even number of 1. Single 1 will be accepted because it contains odd number. 1 1 will be rejected because it contains even number. Q naught upon 1, I'll go to Q naught upon 1, I'll go to Q1, and in Q1 I'll encounter one more 1, which makes it even. I'll go back to Q naught, which is non-accepting, right? And we are not bothered about the number of zeros that we encountered with odd number of ones, right? So even this will be accepted, right? So this is the solution for this problem. We'll see a few more. In this particular language, string is made up of 3 alphabet symbol A, B, and C, and the definition says accept string that contains AAB as a substring. So string should contain AAB, which to be considered as a valid. Okay, to be considered as a valid string belonging to the language. Okay. So let us stick to the basic and design the skeleton of the DFSM by considering the simplest string that is accepted. So what is the simplest string that is accepted according to the definition of the language? The simplest string is of smallest length, right? So A, B itself is the smallest substring. So if I have AAB, the string itself as AAB, then it contains the substring AAB, and it should be marked as valid, right? So we have to build a DFSM by considering this. Okay. So if I encounter Q naught upon A, I'll go to Q1. Q1 upon A, I'll go to Q2, and Q2 upon B, I should go to an accepting state and I'll mark it as Q3, right? Okay. Now simplest string AAB, so this is the smallest length string that is valid. AAB is accepted, right? Q0 upon A, I'll go to Q1, Q1 upon A, I'll go to Q2, and Q2 upon B, I'll end up in Q3, right? Okay. So anything smaller than AAB will be rejected. So if I have epsilon, I'll remain in Q0, which will be rejected. If I have A, will be rejected. AA is also rejected, right? Okay. So let us build the complete FSM based on the skeleton what we got. Okay. Now what if I get B in the beginning? So will that be completely rejected? Should I go to some dead state? So Q naught upon B will be rejected, right? But I shouldn't go to a dead state because after B there is a possibility of encountering AAB, right? So this is a valid according to the definition. So what should I do? When I encounter B, I will remain in Q naught. Okay, because we are thinking of the future possibility, and if I encounter AAB in the future, then that will be accepted. Any number of P's followed by AAB, right? So this will be accepted. Okay. So Q naught upon A and B, both transition we have written, both the possible transition. Okay, there is a C now, right? Okay, what if I get C? C also? If I get C also, I will remain in Q naught. Okay, so any number of C before A, B uh, should also be accepted, right? Okay, now once I get A, in Q1, if I encounter B, what should I do? Can I remain in Q1 here? No, I cannot remain in Q1 because AB, AB. So what will happen? If I remain in Q1, what will happen? Q naught upon A, I'll go to Q1. Q1 upon B, if I have a self loop, then I'll remain in Q1. Then I'll encounter A, by which I'll go to Q2. And then I'll encounter B, and I'll end up in Q3. So this will be marked as accepted, but this does not contain AAB, right? So this will be this will end up in designing a wrong DFSM, right? So I cannot remain in Q1. So where should I go? I should go back to Q naught. Okay, so to go back to Q naught upon encountering B as well as encountering C, right? Okay. Okay, Q1 upon A, B, C, all the three possible transition we have written. Now Q2 upon B, we have a transition. If I encounter C, what should happen? So I'll get what AAC, right? If I get AAC, then I should go back to Q naught state, right? If I encounter C, I should go back to Q naught state. If I get B, of course, I'll go to Q3. What if I get more? What if I get A? Should I go back to Q naught? I shouldn't go back to Q naught because I'll give a example. If I get A, B. So first to A, I'll end up in Q2, and for the next A, if I go to Q naught, then for the B, I'll remain in Q naught, right? But doesn't this contain a substring AAB? Yes, right? So this string will be rejected if I go to Q naught. So what should I do? Where should I go? Should I go to Q1? Even if I go to Q1, I'll end up in Q naught state, right? So I shouldn't go to Q1 also. So where should I go? I should remain in Q2. So what this will do? See, we have already encountered the two A's, right? And if I get one more A, so I'll get three A's, or if I get more number of A also, uh, there is a possibility that if I get B after that, then I should go to accepting state, right? So I should end up in Q3. So in this case I should remain in Q2. Okay, so Q2 upon B we have a transition, Q2 upon A we have a self loop, and Q2 upon C will go back to Q0 state. Now coming to Q3, what in Q3, see we'll reach Q3 only after encountering A, B as a substring, right? So after that, whatever we encounter should be accepted, right? So A, B or C should be accepted. So once I encounter A, B, and followed by that C, any number of C or A, B, doesn't matter. I already have the substring what I was looking for, right? So I should remain in Q3 state. So in this case, I should remain in Q3, which will be marked as accepting. Okay. We'll go to one more problem. Okay, in this language, uh, the string is made up of AB, and the definition says no two consecutive characters are same. Okay, let us build a DFSM for this. So consider the simplest valid string according to the language. What is that? A string of length 0. So epsilon, if I consider epsilon, does it satisfy the condition defined by the language? Yes, right? So no string at all contains no two consecutive in which no two consecutive characters are same, right? So this is accepted. So what will happen? I'll start with the Q naught, okay, and I don't encounter anything, so this will satisfy the condition, right? So I'll mark this as valid. So this is true. So this is the skeleton of the DFSM. Now let us consider let us improvise on this. If I what if I encounter single A? Okay, so is this valid? Yes, of course this is valid because this contains a single character, and this will satisfy the definition of the language. But should I remain in Q naught? If I remain in Q naught, what will happen? Q naught upon A is, of course, this will be marked as valid. But if I encounter one more A, then again I'll remain in Q naught itself, right? But here I have two consecutive characters which happens to be the same, right? I have two A, so I cannot have a self loop, right? So what should I do? If I encounter A, I'll go to one state Q1 and I'll mark this as accepting. Okay, yeah, okay. So this will be marked as accepting. So this, okay. Now, what if I have a single B? Should I go to Q1? If I go to Q1, then for both A and B, I'm going to Q1, isn't it? So that this will create a problem. So what I will do, Q0 upon B, I will go to a new state, which will also be marked as accepting, right? Okay. So what will happen? So Q0 upon B will go to Q2, and that should be marked as accepting. Okay. Now in Q1, if I encounter more A's. So what should I do if I encounter more A's? Can I remain in Q1? No, that is again that will create a problem as we have seen with respect to Q0. So what should I do? Of course I should reject it, right? So if I encounter more A, I should go to state D, and see, since I have already encountered two consecutive A's, so any further whatever I get in D should be rejected, right? So if I get further A or B will be rejected. And the same is applicable. Q0 upon B, I'll go to Q2, and Q2 upon B, if I get B, once again B, then I'll go to dead state, and which should be rejected, right? Okay. So our solution is often, what if I get A followed by B? Is this accepted? Yes, this will be accepted, right? But where should I go, or in which of the three accepting state I should remain? So Q0 upon A, where will I go? I'll go to Q1, and Q1 upon B. Can I remain? Can I go back to Q0? If I go back to Q0, then if I go back to Q0, what will the problem is? If I go back to Q0, of course this will be accepted. But if I encounter one more B after that, then that I will end up in Q2, right? Which is marked as accepting. But here I have two consecutive characters which are same, so I cannot go to Q0, right? I cannot go to Q0. Can I remain in Q1? No. Again, I can have any number of A followed by any number of B's. If I remain in Q1, even this will be accepted. So where should I go? I shouldn't go to dead state because this is AB is completely valid, right? So what should I do? Can I go to Q2? If I go to Q2, what will happen? A, I'll go to Q1, and for the B, I'll go to Q2, which is marked as accepting. And one more B if I get, I'll go to dead state because if A, B, B contain two consecutive characters, which will be rejected. So A, B, I'll end up in Q2, which is accepted. Now, what if I get more A's? Okay, if I get one more A, now I will not remain in Q2 because that will accept any number of A's, and I'll end up in Q2 that will be accepted, but this contains two consecutive A's, right? So I cannot remain in Q2. Can I go to Q0? No, I cannot go to Q0 also, right? So where should I go? I should go to Q1. Okay. Now this will satisfy all our constraints. So what if I get epsilon accepted, right? I'll remain in Q0. Single A accepted, I'll go to Q1. Single B accepted, I'll go to Q2. AB accepted, right? AB or ABA accepted. AB AB will be accepted, and the same goes for BABA, right? This will be accepted. And whenever I get AB followed by one more B, it will be rejected, or BA followed by one more A will be rejected, right? Okay. So these are some of the examples, solutions of DFSM for few languages. We'll see a few more of this in the upcoming session. Okay, I'll see you in the next one. Bye bye.